This is a favorite, and I would say that this problem, I enjoy working with this problem because we do not have one like this coming on the paper or similar to it quite often, and it is basically some deviation from what we normally have. I always welcome something like this on the examination. In completing the table, because we need to complete the table that we have right here, let us first complete the mid-interval values of the classes. We may find the average of the class limits. So the mid-interval, or the midpoints, or the mid-interval values will be halfway between 1 and 10. That may be calculated by adding 1 plus 10 is 11. Divide 11 by 2, we get 5.5. And if we add these, we get 31. Divide 31 by 2, we get 15.5. We can just take a look at this and realize that it is going up by 10 each time. But let us do another one first. So let us do another one first. We have 21 plus 30, and we divide that by 2, and we get 25.5. There. And of course, we are increasing by 10 each time. So the values are in a sequence increasing by 10 each time. So continue the sequence going up by 10 each time. We get 35.5. And going up by another 10, we get 45.5. But what do we know about the other? The height of each bar is the frequency of the respective bar. So the height of the bar is the frequency of the class. So no doubt we have this bar here, which is the second one, going all the way up to 25. And that is why we have the 25 right there. And we have the first one at 18, but let's see what this one is. The next one that we have is right there. So we have 20 here, and this is about 25. So we may consider that that one is about 23. Now on the one that is given on the examination paper, we can determine the values exactly, but we do not have the luxury right here. So for the most part, we can go at an estimation unless we have one is 10, the other one is 15 or 20, 25, so on. Like this one is exactly on 20, so we may just write that down, 20. And then what do we know? 10, 15. So this one is a shade below 15, so we can safely say it's about 14. Right. The mode, we need to determine the modal class. The mode is the item that occurs the most, and its class is associated with the highest frequency. So the mode is the item that occurs the most, and its class is associated with the highest frequency. So the highest frequency is 25. So the modal class is the class that goes from 11 centimeters to 20 centimeters. Right. The number of seedlings in the sample is the sum of all the number of items in the categories, which is equal to the total of the frequencies. So the number of seedlings that we have, the total number of seedlings, will be the total of all of these numbers. And that turns out to be, when we add them, 100. And I was looking a bit at it and say that its addition, the sum, looked to be a little bit different from 100. But when I say 23 plus 14, that gives us 37. And then we have another 18 here with the 37. And that should give us 55. And then we have another 20, so that's 75, and 25 is 100. That's not difficult. In finding the mean, because we need to find the mean now, we need to extend the table, and we have the extended table here. We need additional cells for the sum of f So the summation of the frequency needs to be there, and we need additional cells for the summation of f and the summation of fx, hence an additional column for fx, which is what? This product of f and x. And what do we consider to be x? The mid-interval point, because what we are attempting to do is find, we are adding all of the values, or all of the possible values, and we have 18 of them right here. 18 of what? 18 of 5.5. So 18 values, each one is 5.5, so we multiply the 18 by 5.5. But actually, if the statement of the problem is giving us an indication, then we should take it. It says find an estimate of the mean, because we're not actually finding the mean, because we do not know in the range from 1 to 10 how many are closer to 10 than to 1 or in the middle. So it's an estimate. Since we cannot, or it is not going to be wise to use, and we should not either, because we do not have all of the values inside here. We just know that from 1 to 10 we have 18 values. So it's merely an estimate to say that we are using the mid-interval values, but multiply that by 18. So let us find the product of f and x. That's that. Any more? Yes. 15.5 times 25, and then 25.5 times 23, and then 35.5 times 20. And then the other one, we do not have a statement down here, is 45.5 times 14. Now, the summation of the frequencies was determined from the previous slide. Additionally, we need to find the summation of the product of f and x. So we need to find the summation of fx, and we need to find the summation of f. We have done that from the previous slide. It is 100. So 100 goes there, and the summation of this goes there, which is about 2,420. Right. And how do we calculate the mean? The mean is given by what? X bar is equal to the summation of fx over the summation of f. So 2,420 over 100, and that gives 24.2 centimeters. What is all of this space for? Another problem. Now we need to determine the probability that a seedling has a height greater than 30 centimeters. So the probability that a seedling has a height greater than 30 centimeters will be found by dividing the number of seedlings concerned by the total number of seedlings. Those seedlings are in the class 31 to 40 and 41 to 50. Those that have a height greater than 30. So we have 21 to 30. Those in this category will have heights 21 to 30. But here we have 31 to 40, which is greater than 30, and here we have greater than 30 also. So the number of seedlings in these two classes divided by the total number of seedlings. So we have there 20 plus 14, and that we divide by 100. And we get 0.34, because we get 34 divided by 100, and that is 0.34.